All right, welcome to the solutions video for chapter 11, section AB, recorded lecture. And now if you look over here, I'm going to actually go to chapter 11. So, okay, here it is. All right. So I'm just going to the chapter 11 reference material, and you'll see teacher's notes for chapter 11. So what do I say about chapter 11? Oh, by the way, if you go to chapter 11, you'll also notice there are only two sections. So there's an A and there's a B. That's true, any semester, not just winter. The only change for winter is we're not going to test you on chapter 11 or chapter 12. Chapter 12 is even shorter. It's only one section. But I decided to leave chapter 11 and 12 off of the tests, off of the final. No other test coming up other than the final. So the final stops at chapter 10, but the chapters 11 and 12 are homework only. So it's good to know that. All right, so teacher's notes. Let's look at what we're doing here. So in chapter 11, we really have three topics, three new things in chapter 11. Given 2 points, x1, y1, and x2, y2. So I guess we call this first one, point 1, because it's x1, y1, and the second one, point 2. So given point 1, point 2, we can calculate, we don't have to draw this and measure it, we can calculate the distance. And notice the formula, x2 minus x1 squared, y2 minus y1 squared. Now, there is the Pythagorean theorem kind of behind this, but you can watch the videos if you want to know the whole story behind this. But you just want to make sure you have that formula ready to go. And so what you're going to notice is a lot of the questions about distance between 2 points will have a square root in them, because the formula itself has a square root. Now the square root could go away if this calculation, worked out to be something where the square root would go away. That's fine. But if it didn't, we need to simplify the radical. All right. And then the other thing we can calculate is the midpoint. So the midpoint, and you might recognize these formulas, x1 plus x2 over 2 is just the average. The average of two numbers, you add them together and divide by 2. So it's the average of the x's, the average of the y's, and if you average the x's, average of the y's, what you're going to find is the midpoint, the point directly between the 2 points. Notice the parentheses and the comma. The midpoint is a point. It's got an x value and a y value. So the parentheses and the comma is part of the formula, part of the answer. And then finally, the equation of a circle. I feel like we've been kind of leaving hints for this for a while. Actually, I wish I had added to this, but if you just had x squared minus y squared equals r squared, you have a circle centered at 0, 0, the radius, the origin. But if you replace x with x minus h, actually, I'm going to lecture while I say this. So let me take this formula. That's it. That's the end of the notes. And explain it a little bit with some words here. All right, so I'm leaving that part of the problem there. And let me talk about the circle formula again. So x squared plus y squared equals r squared. Notice all the squares. This is a circle centered at 0, 0. So if I had, or centered at the origin, so if I had my x and y axes, and I drew this circle, that's a circle centered at 0, 0 with a radius of 2, the formula would be x squared plus y squared equals r squared. You wouldn't see it written this way. You'd see the 2 written as x squared plus y squared equals 4. Let me draw another one in a different color, right on top of this one, essentially. Let's draw this circle. That circle is going to be x squared plus y squared equals 3 squared, or x squared plus y squared equals 9. That's the way you're going to see it when you see the equation, because you normally don't write 9 as 3 squared unless you're trying to make a point. All right, so that part is new. You haven't been told this before, but circles have this formula, x squared plus y squared equals r squared. Now, there's a rule we talked about before, and that is, what happens if you replace x in either of these formulas with x minus h, and you replace y with y minus k? Well, hk becomes the locator. Or in this case, the center. So locator, I don't even know if I spelled it right, equals the center. Again, locator is kind of my own term. You don't see that very many other places. So the preferred word, I suppose, will be the center, because we have that word available to us in this situation. Now, you didn't need to know that whole argument that I just told you, the whole story. You could have just done it the way they normally do it, and that is, here's the formula. HK is the center, and R is the radius. But I feel by kind of explaining to you where this came from, where it started with x squared plus y squared equals r squared. And then we did the thing we did before with the replacing, h and k. It puts it into perspective that you'll remember. All right. So with that, and our two formulas, we'll jump into it. All right, let's look at our first question. So the first question actually has the formula. In other words, it's typed. It gave it to you. But what was the formula again? It was the square root of x1. Well, usually it's x2 minus x1. Yep. Squared plus y2 minus y1 squared. And if you remember that formula, you would use these numbers. This minus this, 8 minus 5. All right, so let's calculate that. It's going to be the square root of 3 squared plus 3 squared. Now, I know it's negative 3, but I'm ignoring the negative because I'm squaring it. So 3 squared, 3 squared, square root of 9 plus 9 equals the square root of 18. I wouldn't leave it as the square root of 18. I would simplify the radical as 9 and 2. And of course, the square root of 9 is 3. And copy the square root of 2. Run that through a calculator, or even better yet, run square root of 18 through a calculator. That's usually a little easier to calculate. Run square root of 18 through a calculator, and you'll get 4.24. X minus h squared y minus k squared equals r squared, and we're just playing a matching game. And it's a matching game we've played before. Minus h matches with plus 8. Notice I said minus h, not h. Minus h matches with plus 8. So if minus h matched with minus 8, well, let's do that first. Let's do this one. Minus k matches with minus 4. So k is 4. But minus h matches with plus 8, so it's not plus 8. Adjust the sign. It's minus 8. All right. So h comma k is the center or the locator. Minus 8 comma minus 4. And then this matches up to r squared, not r. So r isn't 9. R squared is 9. R is the square root of 9, or 3. We have these points. We want to find the midpoint. So the midpoint, 6 plus negative 3 over 2, and negative 4 plus 2, or 2 plus negative 4. The order doesn't matter. I'm adding them. Let's do negative 4 plus 2 over 2. I might have done that in an unusual order, but just add the x's and add the y's. All right. So what do I get? I get 3 over 2. And here I'm going to get 2 over 2. I wouldn't leave it as 2 over 2. And actually, it's negative, isn't it? Yeah. Negative 4 plus 2. Yeah. Negative 2 divided by 2 is negative 1. And again, notice that we actually type in the parenthesis and the comma. Was it that fast? Yeah. It was just asking you for the midpoint, so you just wanted to find the midpoint. Oh, nope, I missed something. Find the distance. Where'd that come from? All right. I need those points again on the screen. The formula. Sorry, it's off screen for now. I'll scroll up in a second here. Midpoint's really fast. Distance, a little bit of calculation. So the ordered pairs were negative 3, 2, and 6, negative 4. Let me double check that I copied those. Yeah, signs would ruin us. All right. So it's 6 minus negative 3. Now, I haven't done 6 minus negative 3 before. Remember, I did 6 plus negative 3 for the midpoint. And then divided by 2. I do 6 minus negative 3, or x2 minus x1, or and I'm just taking a cough drop break here. All right. For y's, it's minus 4 minus 2 squared. So I'm going to get 6 plus 3 squared, negative 6 squared, I didn't know this number was going to be so big. What is it? 81 plus 36 1 27. I gotta find, gotta find what that is, all right? It's 9 times 13. So it's the square root of 9, rather, square root of 13, or 3 square root of 13. All right, well, you know this was coming. It's chapter 11. There's going to be some chapter 8 in it, at least at the end in this case. Again, x minus h squared, y minus k squared equals r squared. H is -4, k is 3, and r is 2. So remember that, -4, 3, r equals 2. -4, 3, with a radius of 2. So tap that point, and the circle will appear when you're using the tool, graphing tool. I'm a little worried about how big these numbers are going to get. All right, so this time I want to use the, what are you asking for first? The distance formula. All right, I'm going to use the distance formula on this. So this is x1, y1, x2, y2. And I'm going to plug those into the distance formula. It is negative. I was starting the wrong formula. I was starting the midpoint formula. Midpoint formula is the one that starts with a parenthesis or a bracket. I want the distance formula. All right, just going to have everything migrate into place. Remember, it's x2 minus x1. So I'm looking up here, -1 minus -5/2. I'll fix the signs in a minute. And it's -5/2 minus 5. And it's off to the races from here. Well, not quite. Let's change the signs. Nothing to change here. -5/2 minus 10/2. Want a common denominator there. I guess I should do that here. Let me back up and think ahead here. -1, I can think of it as -2/2, right? Because it will give me a common denominator. So I will get 5 minus 2, which is 3, and -5 minus 10, which is 15, -15. It's -15, but it's squared, so sign could have been ignored. Let's see, this is going to be 9/4, and this one's going to be 225/4. So altogether it is 234/4. So I see where the 2 comes from. Now 234, I'm going to cheat a little bit and say, now I do know 234 adds up, the numbers 2, 3, and 4 add up to 9. And that's a trick we probably haven't talked about yet. But when the digits add up to 9 or a multiple of 9, I know that the number can be divided by 9. I really would put a calculator on this if I were, trying to do this problem kind of at random. But anyhow, 9 is is not that much of a stretch. And it's one of the first numbers you try in a calculator. But if you did that, you'd get 9 divided by 26. 3 square root of 26 over 2. Doesn't reduce from there, but 3 square root of 26 over 2 was the distance. Now, for the calculation, I'd probably do it over here. Tap the square root button, parentheses, square root on a calculator, 2, 3, 4 divided by 4. And just see where that takes you. All right. It says a portion of the circle, it will extend beyond the grid, and that's okay. So just reading it from the picture, from the equation. -2, 1, and 8 are our magic numbers. -2, 1 is the center. 8 is the radius. Once I go to -2, 1, I notice that I will leave the box if I try to travel in certain directions. And let me actually do this one on the grid. So let me find the homework. I was in chapter 11, the actual chapter 11. Let me just demonstrate the graphing tool. And I'll do it on that particular problem, which was problem 6, yeah. All right, so here's my graphing tool. It's already activated. And I want to tap the first point. And then I want to tap a point 8 away from this. Now, can't go in certain directions like I said, but I can go in this direction to the left. 1, 2, 3, 4, 5, 6, 7, 8. And notice I have a circle. It's not because I've zoomed the camera in or anything. I have a circle that left its box in a couple of places, but that's not a problem. If, and it's one of those common issues with graphs. Sometimes a graph just isn't big enough, so you graph what you can, and the computer does that fine. I will say it's students, though, back to this, who sometimes will say, wait, I always go up. Well, why? You have four choices. If 2 of them are removed, try another choice, all right? You want to be 8 units away from the center, and you can go in any of those directions, all right? So again, this one, it wasn't your job to do any graphing. It's already there for you. You just want to know what points those are. So this point, and enter their ordered pairs. So really nothing for us to do other than the ordered pairs on that one. No graph on this one. We're going to solve this algebraically. And by the way, we couldn't really use elimination method. That's really the only game in town is graphing or substitution. So what's substitution? You have this formula, y equals something, 4x minus 17, And that allows you to put that value into the other equation. So I'm going to copy this as minus 4x minus 17 equals minus 2x squared plus 5x plus 28. And I'm going to solve this like it's chapter 4. I don't know what chapter. I really don't know what chapter is going to be involved because if it needs the quadratic formula, maybe we're looking at chapter 8. If it doesn't, maybe we're looking at chapter 6, just factoring. But I definitely want my 0 side, minus 2x squared plus 9x plus 45. So let me multiply by -1. So we can do that. We can always multiply both sides by whatever we want. So I'm going to multiply both sides by -1. And that just changes the sign. So 2x minus 2x squared minus 9x minus 45. And then let's factor. And 45. What numbers do I think of when I think of 45? Well, numbers close together would be 2 and 9, but I think I've tried this problem, and it was 15 and 3. Because I get 6x and I get 15, and with a 6 and a 15, I can make a 9. Right? Negative 15 plus 3. Now we do have other choices, of course. We could use a quadratic formula, all right? But I still like factoring. And I'm going to get 2x equals 15, or x equals 15 over 2, and x equals -3. And notice I said x equals, right? Solve x equals. What's important here is we're going to have two answers, and x goes before the comma. So in no shape or form should I put these together into one ordered pair. In other words, putting 15 over 2 comma -3 would be putting x, we're in the y spot. Yeah, don't do that. It's x, y, x, y. All right, so these are my x's. So how do I find y? Well, let's take the simpler of the two formulas. Y equals minus 4x minus 17. And let's plug in 15 over 2. If I put in 15 over 2, I'll get -30 minus 17, or 47. Yeah, -47. If I put in 3, I get -5. So, and I'll just do that one without writing anything down. If I put in 3, I'll get -3. I'll get 12 here minus 17. 12 minus 17 is 5. So those are the two solutions. This is x minus h, but h is, well, nothing. I'm not subtracting anything, so, described this one earlier, that this is a circle centered at 0, 0 with a radius of 2. So use the graphing tool to get that image. Sorry, off the screen a little bit. All right. And then this line. Now, I graphed it earlier with a table. If you don't use a table, I suppose you could do it, bring the x to the other side. You'd have minus y equals positive x plus 2. Change the signs. Multiply by -1. And you'd get y equals minus x minus 2. So minus 2 is the y-intercept, and -1 is the slope. So the line would look something like that. All right, where did they meet? You don't need to plot it. We don't have the point plotting tool. It's not even there. We don't even have the point plotting tool. But they just want to know the ordered pairs where they meet. So these are the ordered pairs. -2, 0, and 0, -2. And that would be that solution. I feel like I already talked about this one on the other video. But if you're not watching the other video, let's do it. All right, to do this for our computer, all right, you just need 2 points for each graph. So I would pick the standard points for a logarithm. 1 and whatever the base is. Base is 2. It's always 1, and it's always the base. Because those are easy to calculate. Log base 2 of 1 is 0. It's the exponent I put on 2 to get 1, 0. Log base 2 of the base is always 1. Because what x, I just wrote a 2 on top of that. Let me draw it. It's log base 2 of 2. All right. What exponent would I put on 2 to get itself? Well, 1. All right, that's all I need for this particular graph. I'll go ahead and switch to the graph, active graph here. Oh, and let's think about this one. Slope is 1/4, and the y-intercept is 1. So let me go ahead and graph it live, or on the active page here. So to graph the parabola, or the logarithm, it's these two magic points, 1, 0, and 2, 1. And then switch to the line graphing tool, and it's a y-intercept of 1 and a slope of 1/4. So these are the points that I use to graph it. All right, I use those 2 points, I use those 2 points, but where did they meet? That's the last part of this. And you gotta kind of look at it. Let's zoom in here. They meet here and here. So the point 4, 2 and the point 8, 3. Now, some of these points might not have been on my radar, and by my radar I mean on my table. And that's exactly what graphing does. Sometimes graphing discovers something you wouldn't have known, right? In other words, I didn't use 8, 3 to graph either of these, but 8, 3 was, and would be a solution to both equations. So again, the solution 4, 2, 8, 3. I think I skipped a question. Man, okay. I guess you'll notice that there's no question 11. on the, and it wasn't on the last video. I'm going to leave that and apologize as, I don't know, find another way to inform you of that answer. I'll tell you now, but let's do this one, 12. I'll get back to 11. All right, so this one, we have two things to graph, and they are well, I need HK and R. So HK is 1, -2. R is 3. You can see where I'm looking here. Get that, and then this line here. All right, pretty straightforward if you know the routine. 1, -2, R is 3, that gives you a circle, and then to draw the line, and that tells you where the two lines meet. I wouldn't have known where the two lines met if I hadn't done the work. Once you know where the two lines meet, call this point A and point B. A is -2, -2, and B is 1, -5. You would put those in the answer. All right. What did I forget? All right. Okay, this is an interesting one. Graphing method is not precise enough to find the answer involving a fraction, like 14/5. So it wouldn't work in this case. I mean, I couldn't even graph this circle. I mean, how would I go square root of 26, right? R is the square root of 26. What is that exactly? 5 point, but I mean, how would I even do that, right? And then this line. So we don't have the option of graphing, or at least we wouldn't have the accuracy if we tried to graph this. So we're going to do the substitution method. We take the equation we had for the line and solve for y, and then we're going to replace y in the other equation. So this is pretty well written out here. X squared plus y squared equals 26 is the second equation. But with the substitution, y is going to change to minus 2x plus 11. Now notice all I have is x. Five x squared minus 44x plus 95. And we either factor or use the quadratic formula. All right. I don't know. They said the quadratic formula, but factoring would work. Let me show you that part at least. If you have 5x squared minus 44x plus 95 equals 0, we could factor it as 5x of x. And you know, sometimes it's obvious, it's a little more obvious if you already know the answer, but I don't know, 95 is really only showing one thing, right? 5 times 19. I can't put a 5 with a 5, so this is what I'd try, and I'm liking what I'm seeing. 25 and 19 for a 44. Yeah. So I could factor it, and I get 5x minus 19 equals 0, x minus 5 equals 0. I'm going to get x equals 19/5, and x equals 5. Now the whole reason why I couldn't have graphed this was, well, two reasons. I'm not going to get a graph of square root of 26. That's just not, you know, if I go left, right, I just couldn't plot that point. It's one of the limitations of our graphing software is it doesn't let us plot things like square roots of numbers like that. So in other words, if the address, if this had been a 25, I would have had the square root of 25. I could go 5 to the left or 5 to the right, but I can't really go square root of 26 left and right. All right. So I need to substitute these two values into either equation. Actually, I shouldn't even say either equation. I definitely wouldn't want to put it in the circle. I'd put it in this equation, right? If x is 19 over 5, put x here. If x is 5, put x there, and that will help us calculate y. So they did that. When x is 19 over 5, we get 17 over 5 for its y value. And when x is 5, we get 1 for y. So those would be the answers for that particular problem, which I just did, which was 11. Problem 11. Kind of did it out of order just because I didn't have question 11 on my list of questions. All right. Well, that's everything for that section. It is chapter 11, and it's not on the test, and nothing's built on this. I mean, in other words, chapter 12 won't require this knowledge exactly. But I do find it an interesting chapter, and if you need homework points, I mean, you know what I do with some of the homework. We have the default scores and that kind of thing, but if you need the credit in the homework, I highly recommend you at least go through the chapter 11 and get the homework points. All right, that's it. Take care, everybody. See you in class.